Okay, we're here with Luke and Jordan to talk about dividing exponents. So quickly, let's do an exponent review first. So remember, an exponent is the number of times you multiply the base by itself. So with 8 to the 5th here, 8 is the base, 5 is the exponent, and so that 5 tells you I'm going to take 8 and multiply it by itself 5 times. Make sense?
Yeah.
Okay, good. That's review. Now, so let's just really quickly tell me, Luke, what should I write out here for 2 to the 4th if I were going to write it out like I did with the 8s up here?
2 times 2 times 2 times 2.
Perfect. Okay, so it sounds like you guys have it. Okay, now let's talk about multiplying really quickly, which is something you guys have probably done. You probably remember there's a rule for this, but before we get to the rule, I have 7 to the 3rd times 7 to the 2nd, or 7 squared, and I write it out like that. Now, Jordan, why do I write the left-hand side like 7 times 7 times 7?
Because the exponent is 3, so you multiply 7 3 times.
Good. You multiply the base 3 times, 7 times 7 times 7. We do the same thing over here for 7 squared. So what's the total of that going to be, Luke? 7 to the what?
7 to the 5th power.
Good. And so we also know that the rule, therefore, is we have a 3 and a 2. We know that adds up to 5. So when multiplying, add the exponents. So when we're multiplying here, as long as it's the same base, like 7 and 7 here, we can just add those exponents. Make sense?
Yeah.
Okay, now let's talk about dividing, which is a totally different thing here. Let's do another example, and here we're going to go 5 to the 6th divided by, which is what a fraction is, 5 to the 4th. So does that make sense to you guys that that's division?
Yeah. Mm-hmm.
Okay, good. So we're going to do the same thing. We're going to write it out like we did over here, and eventually we'll fill in what this means here. But first, let's go ahead and write it out. So here I have that 5 to the 6th. There's 6 5s up here, and I have 4 5s down here for 5 to the 4th. Does that make sense to you guys?
Yeah.
Okay, good. Now, one of the things you'll probably notice is if you took this 5 on the right and divided it by that 5 right there, because this is just division, what's 5 divided by 5?
1.
1, right? So what we can do is we can say those cancel out, right? Because they're just going to be 1. And do you see any other things that can cancel out?
Yep.
A whole bunch more 5s, right? So let's go ahead and cancel all the 5s that can. So we canceled out 4 of the 5s up here and all 4 5s down here. So what's left on the top here? Luke, what's left?
2 5s.
2 5s. So we can write that as 5 to the 2nd power, right?
Right.
Mm-hmm. Okay. So then we know that this thing up here is just this written out. So we can write that 5 to the 6th divided by 5 to the 4th is 5 squared. Okay. Now, do you see any relationship between the 6 and the 4 that can kind of get you to the 2? Luke, do you see any relationship there?
Yeah, 6 minus 4 is 2.
6 minus 4 is 2. So we can come up with a rule here when dividing. This is very similar to the rule for multiplying. When dividing, subtract the exponents, and still it must be the same base. Does that make sense to you guys?
Yeah.
Okay, good. Now, let's try a couple of examples here. How about x to the 10th over x to the 3rd? Remember our rule here. And Jordan, go ahead and tell me what this should be.
X to the 7th.
Yep. Easy peasy, right? Just do a quick subtraction. Let's do another example here. Ooh, this one's a little bit more difficult because we have both numbers here, coefficients, and we have the variables. So let's do the numbers portion first. We'll kind of separate that out. So what's 15 divided by 3, Luke?
5.
5. So we'll write that portion, okay? And now, what's this a down here? What's the exponent on that a, Jordan?
1.
1, even though we don't write it, right? So now that we're going to apply our rule of subtracting. So what should the a be? It's 3 minus 1, so it will be
Squared.
a squared, right? Okay, and let's do just a little bit more examples down here. So we have another kind of a puzzle example right here, okay? So we have 3 to the 8th over 3 to the x equals 9. So like I say, this is a little bit of a puzzle. But if we just paid attention to the left-hand side here, can you think of, here we have x to the 10th over x to the 3rd is x to the 10 minus 3. What if we wrote this left-hand side kind of the same way? Can you guys think of how we might write that?
Negative 1.
And what's the negative 1 coming from? How are you getting that?
Because 8 minus negative 1 is 9.
Ah, okay. So you're paying attention to the right-hand side. Good attempt on the puzzle. But let's just pay attention to the left side over here. if we were just going to say this is 3 to the something, it would be 3 to the 8 minus what? What's down here?
X.
X. So we could write that left-hand side as 3 to the 8 minus x. Does that make sense to you guys?
Yeah.
Yeah.
Okay, so that's a little bit tricky because you wouldn't think to write it out that way. And then we know that it equals 9, right? Okay.
Yeah.
Now, we also know that 3 to some power equals 9. Can you think of what that power is?
To the third power.
Well, 3 times 3 times 3, is that 9?
Sorry, to the second power.
To the second power, 3 squared, right? So we know that 3 squared equals 9. So now look at this. 3 to the second power equals 9. And 3 to the 8 minus x equals 9. So 8 minus x must be the same as what?
3 squared.
Yeah, 8 minus x must be the same as 2, right? Because it's the same exponent. These things are equal to each other. So we could write that out. 8 minus x equals 2. And then 8 minus what equals 2?
6.
6, right? So we can figure out our little puzzle here that x equals 6. Now this one's a little tricky. You might see problems like this on something like the SAT to get into college. But really it's just applying what you already know. That when you divide, you subtract the exponents, and you can even figure out puzzles like this. Make sense?
Yeah.
Great job, guys.